Okay, this is my third time at recording the audio for this video. Why am I in this predicament? Mainly because I've used Prezi to try and present something that looks quite interesting and quite engaging for students. The problem is I decided to use the latest version of Prezi, which is Prezi Next, and Prezi Next does not allow audio to be recorded over the top of the slides or the presentation components. So those of you who are using Prezi, continue to do so. It's great, but make sure you use Prezi Classic to make sure that you can record sound if that's what you want to do. At the moment, I'm using QuickTime to add an audio screen, an audio layer to this presentation. So we're going to talk about videos. Let's have a look. So why do we want to use videos? We want to use videos because they provide a different arm to our teaching skills. So students will engage with videos where they might not engage with other things. Students that are really quite good students might just get a little bit of kick of life, a little bit of novelty from engaging with a video. Videos also can demonstrate skills. They can provide access for students to areas of the world and fields of endeavour and education that they can't see in the classroom really easily. And videos provide that medium for them. So they're really quite powerful if we can use the right videos for the right learning situation. What are we looking at here? We're going to try and understand how video works. We're going to talk about how we might communicate our videos once we've created them, and in between toss in a few tips about how we might make slightly better videos. So what is a video? Well, videos are essentially just a file, like pretty much everything else that we use. It's like a Microsoft Word file or an Excel file or a Photoshop file. They're all files that have their own particular attributes. Now, videos are different in a number of ways, but mainly because they are very, very big, and they can cause, and that size can cause a significant problem in terms of creating, editing, and storing of them. They have different types, just like Word has different versions of the text that you type, and it requires different software to develop and play them, and some of that software isn't compatible from machine to machine or from operating system to operating system. So, characteristics. There's lots of characteristics of video, and that can be really confusing for some people, like many people. There's lots of resolution information, there's things about frame rates and bit rates, there's audio types, different types of audio, compression and codecs of compression for videos, there's lots of different format types, the containers. All of these things affect the quality and the file size, and it is important to have some understanding of all these attributes so that you can actually make the video that you want to make, that can be accessed by the people that you want to access it. So let's have a look at the resolution. Resolution is essentially the number of pixels that are displayed in the video. So a very simple video might have 4 pixels in it, just 4 different colors, and they just change colors. Very, very boring. And to see a particular movie or something like that, we actually need to have quite a number of pixels so that we don't see that blockiness that you might have seen in some YouTube videos, for example. So STTV uses 720 by 576 pixels. 4K TV uses up to 4096 by 4608 pixels. So that's 4000 pixels on the X direction and 4000 pixels on the Y direction, or the breadth of the monitor and the height of the monitor. Most big monitors have very high resolution, and HD resolution tends to be the soft point at the moment, where it's quite cheap to make the screens and also to communicate video material online at that resolution. The bigger the resolution, the greater the detail, which is wonderful, but also the bigger the file size, and that can be problematic. So, for example, those of you that might have Netflix and internet connections, you might not be able to watch HD versions of your movies that you're looking at because they keep glitching and they pause for a while. It might be because your internet connection is not fast enough to communicate them at that sort of speed. If you half the resolution, you quarter the file size, and that's really important. Size matters a lot in terms of communicating videos to your audience. Okay, let's have a look at frame rates. So, essentially when we're looking at a video, what we're looking at is a whole bunch of still pictures that change very slightly from one picture to the next, from one frame to the next. Your standard movie is 24 frames per second, and at that speed, your eye can't see that you're actually changing from one still image to the next still image. What your eye picks up is smooth motion. Essentially, what you're doing is you're pushing more detail to the screen per second. You get less blurring, more clear change in flow of the video, more detail throughout. So, the faster the frame rate, the smoother the motion, but the faster the frame rate, the bigger the file. Bit rates. Essentially, it's the amount of data that needs to be transmitted per second to meet the quality of film required. So if we want to watch a HD video, that's going to take many more bits of information, binary numbers, 0 and 1, that's a bit. It needs to have more of those transmitted per second than an SD quality video might. So we essentially decide what quality we need to communicate and what we might need to make sure that the audience can perceive all the information that we want. So if the video has got to have lots of high levels of detail, it's going to need more information pumped through to the mobile phone or the laptop computer per second to make it really clear to the student so they can see the detail that you want them to see. So the more bits per second, the better the quality as a rule. Of course, what we're beginning to see is the pattern here. The more bits per second, the bigger the file. The pattern we're beginning to see is that the more quality we want, the bigger the file needs to be. And that makes sense at an intuitive level, but it actually makes sense from a mechanical level for the videos as well. So, if we've got a video signal that we want to send out to some other people, want to share it with our friends or share it with our students, and we want to do it in high resolution, so a HD signal, running at 30 frames per second in America, the NTSC standard, or at 25 frames per second in Australia, the PAL standard, then what we actually need is a bit rate of about 1.5 gigabits per second. That's not gigabytes per second, that's gigabits. So a gigabit is 1/8 of a gigabyte. Bit rate required 1.5 gigabits per second. That's tremendous. That means every second we need to get 1.5 gigabits of information coming to the device that's trying to look at this video. Now, there's not much that can do that. Fiber could possibly do it if you've got a dedicated connection, but otherwise you're not even going to come close. Modem load speeds are around about 56 kilobits per second. Lots of parts of the world are still on modems. Bear that in mind. My home connection, which has just recently been connected to the NBN, runs at about 20 megabits per second. That's still nearly 100 times too slow to look at the video in that quality. Even South Korea, with the fastest internet in the world, still sits well below what is required. So we need to be a bit clever about that. So what we do is we compress the video in a way that doesn't damage the quality of it too much. If we have a look at this screen that you're seeing now, you can see that there's lots of blues. There's a big dark blue circle in there with some writing on it, but nothing's changing over time. So the compression algorithm says, you know what? Nothing's changing here. This frame here, I'm going to store this frame right now in high quality, and I'm not going to change anything until something changes on the screen. Also, even if this was moving, a lot of the content wouldn't change too much. So if the blue circle stayed still and the text changed, well, most of this is blue circle. So what the algorithms do is they go, well, most of you is a blue circle. I'm just going to remember that you're a blue circle and not worry about the fact that you don't change. And I'm not going to store any information. So compression algorithms do some really clever stuff based on the characteristics of video. So compression is required, especially if you're trying to transmit video to sectors of the world that don't have great internet connections. How do we compress? Well, we've probably run .mov or .avi files before to watch a video. They're called containers. There's basically software artifacts and they house the video information. It's essentially just a bundle of files. Within that bundle of files is a compression algorithm that's been run over the top of them. So essentially all those files have been compressed in a particular way, and you might have heard of things like MPEG-2 and MPEG-4 or H.264, which is very common these days. Essentially, it means that you might have a file system that some software which will run a particular container, but it might not support all the different codecs. That's why on occasions we get videos sent to us, and even though it looks like we can run it, it might be an MP4 file, we can't actually run the video itself because it's being coded in a certain way that we actually don't have access to. And that can be really problematic. So in lots of cases where, particularly where students post videos up, they post them up in crazy formats that are actually unreadable by lots of people. And they don't seem crazy to the students. It's just that not everyone has the same software, not everyone has the same capabilities of running particular compression algorithms within particular containers to see the video. So you can see there's potentially quite a significant problem there. Before we get to the solution there, let's just talk about how we might build our videos. Okay. Typically what you might do is you should work at the highest standard you possibly can. So record in the highest quality you can, make all your editing changes, if possible, to the highest quality video source and audio source that you possibly can. Essentially the rule for video is garbage in, garbage out. It's not going to get any better if you don't record it at the highest possible quality. From there, you can make smallish MP4 files that might run on PCs or mobile devices. You might want to avoid videos that have .mov or .wmv extensions because they might not run on everyone's machines. You definitely don't want to make your videos again next year, so try and think of ways in which you can make videos about things that don't change too rapidly. Use any recommended audio compression. Don't worry too much about audio compression as long as it sounds good. It doesn't take up much space relative to video, so it's not really a problem. So, preparation. At the moment, I'm just reading from some notes that I've got jotted alongside me, and so that's enough for me to guide my way through. So I might fumble a little bit over the words, but essentially I know where I'm going and I know what I'm going to say. If you were even more organized, you might choose to script out everything you're going to say and then upload it onto teleprompter software, which might exist on, say, a tablet, like an iPad or even on a mobile phone, and you can read it off of that. So it can actually make the delivery much smoother. You will need to do multiple attempts before you get it right. When you're recording, make eye contact with the camera. Know where the lens is and look at it, because that's where the audience is looking through. So it's quite disconcerting to watch a video where someone's slightly off to one side and think they're looking straight ahead at their monitor, but the camera's in a slightly different position, and it often looks quite odd. You don't quite match eye contact with the audience, so to speak, and therefore the level of engagement and interactivity drops away just a little bit. It's a distraction, essentially. And keep distractions to a minimum. Typically, if you're recording, say, a talking head where your face is there and you're talking about something interesting and you're very enthusiastic about it, there's nothing worse than having something really interesting behind you that actually draws the attention of the audience away from what you're saying and what you're doing to something behind you. So if you've got some great books or some great toys or whatever it is you've got behind you, try to cover them up so that people aren't distracted by whatever it is in the background. The advantage of that is when you compress these things, you don't have to worry about it. So the file size is reduced because the background behind you is relatively plain. It doesn't change much over the time of the video. Whereas if you're trying to record fine details of book titles and things like that, every now and then the compression algorithms have to take a really detailed snapshot of what's going on there so that you don't lose resolution for the video. Essentially, don't distract the audience in any way, look at the lens, and don't have anything interesting behind you. Where you can, just cut away everything that's not important. So once again, if it's a talking head or you're looking at a dog or something like that and the dog's the focal point, you don't need to have the park behind the dog, you don't need to have playground equipment that's next to the dog, you don't need anything like that, just focus on the dog. Crop the size of the video down. That reduces the video size overall and makes it easier for people to download your video and engage with it. So, distribution. Some of you may well have tried to email a video to someone and got quite a shock when you saw how big the files were. You can put them onto DVDs if you've got a DVD burner. You could maybe upload them to learning management systems if you've got those. But essentially, that requires you to have a better understanding of what compression is and the general makeup of your video than you might want or need. So what you could consider is something like YouTube, where you can actually upload the video to YouTube and YouTube takes care of everything else. Create your own channel or borrow someone else's, upload your video to YouTube. Note that it will take some time. If your file is really of great quality, it will take some time to upload it up to YouTube. So you might want to consider doing that from university or from the school that you're at, which has probably got far faster internet speeds than you have. Once it's up in YouTube, then YouTube does all the work. It says, okay, I will compress and I will encode this as much as I want to based on what it is that the user's doing. So a user with a mobile phone might choose to watch a video from YouTube, and YouTube goes, well, okay, you're just using a mobile device. You don't need to have a 4K video being transmitted to you. We're going to send you something of much lower quality. It's still going to look great on your mobile phone, but it will not eat up your bandwidth or your internet allowance too much for you to watch that video. Similarly, if you're on a desktop with a great monitor and you want to watch stuff in 4K and you've got the internet connection that allows you to have that 4K downloaded, then you can set YouTube to basically download a 4K video and watch it. So, recommendation is essentially use YouTube to wash away all of the worries that you might have about what compression is, the size of your video, all of those things. Before you load it up to YouTube, make sure you've done some of the other preparatory stuff, like looking at the camera, avoiding distractions, cutting the video down to an appropriate size physically, so that you're actually only going to ask your audience, your students essentially, to download video material that is relevant to them and doesn't contain a whole bunch of extraneous material that's just eating up their bandwidth. And that's it. Videos.